And welcome back to the Turdferg Show. All right, so today's video is on Hess's law of heat summation. So let's go straight into it. What in the world does this mean? How can you tell you've got these Hess's law problems? Well, look, you've got a bunch of reactions. Look at these examples I've got for you to do. Look at this last one. Oh my goodness, there's little things going everywhere. Now, if you're to this point, you're supposed to already know what delta H means, and that means enthalpy. You should have already have seen that, and you're familiar. If you don't get that, then this is kind of pointless. But here's what's happening. Some reactions involve multiple steps. It's not as simple as just this. The problem is not as simple as that. So they have multiple steps in the problem. So really what you're looking at is this. This problem has 1, 2 steps, and then this is like your answer. And people sometimes call this the net reaction down here is what they refer to it as. So in other words, the end result of these two reactions is this reaction. And so what happens is this. It's giving you a delta H for each step of the reaction. And now it wants to know, so what is delta H for the entire reaction? And that's all these problems are looking at. Well, all you have to do is look at this. Nitrogen plus oxygen makes 2NO. But look, the reaction doesn't end. If you make this nitrogen monoxide in the presence of oxygen, it continues to react. So the 2NO reacts with the oxygen and makes 2NO2. So the net reaction is this. The net reaction says if you take nitrogen and oxygen react, this is the actual product you make. And that's what you got. Now, this problem is real easy. I want to talk to you, though, how you know how your thought process. First thing you need to do on these problems is look at the answer. If you see an N2 on the left in the answer, you need to make sure there is an N2 on the left up here. So that would be step number 1. Is there an N2 on... No, I don't want to change my color scheme, you idiot computer. Is there an N2 on the left side of this reaction? No. Yes. So that's where I'd be like, check mark. Cool. There isn't. Now I need to look. I need an O2 on the left. Yeah, technically I need 2 O2s on the left, but the 2 is not my priority at this time. All I'm looking is to see, is there an O2 on the left up here? And when I look up here, yeah, there's an O2 and there's an O2. So both of those. By the way, this would be a good time to give you a hint. Do you notice anything about how I wrote like my pluses and my arrows in this problem? One of the best hints I can give you is to kind of keep everything in a line like this. If you write these all scrambled up, they become a pain in the butt. So that's why all my pluses are in a line, all my arrows are in a line. Here, look, here's another one that I wrote. And if you look, I did the exact same thing. Everything's kind of lined up. And the last example I'll do, I did the exact same thing. I tried to keep all these arrows in a line through here. And it really does make these problems easier. So going back to this one. Now, I need to do one more thing. Look at the answer. I need an NO2 on the right. Technically a 2 NO2, but I'm not going to look at... Oh, man, it's about to get on. I don't know what you're doing popping up in my face like that, but I tell you. Anyway, Turdferg getting crazy. All right. So if we take a look at this, I need an NO2 on the right. So look up here. Is there an NO2 on the right? Yes. So that is the first step in all these problems. Now, the second step is this. All right. I need this. I need 1 N2 in my answer. So look up above, and is there a N2 in the answer? Bam. I need 2 O2s in my answer. So look up above. Do I have 2 O2s up here? Yeah. 1 and 1 O2. So I got my 2 O2s. I need 2 NO2s in my answer. Now look up here, and I got my 2 NO2s in the answer. Bam! This is so easy. You know what I don't need in my answer? Look at this. I don't need an NO in my answer. But check it out. There's... Holy cow, what is your malfunction, guy? Look at what I've got. I've got 2 NOs on the left. Hey, stop looking at this in terms of like 2 equations. Look at this up here as like one big equation. So look at it this way. I've got 2 NOs on the left, and 2 NOs on the right. What happens to those NOs? 2 NOs, just like math class. If you had 2x on the left and 2x on the right, what would happen? Somebody says they cancel. You're right. So those cancel out, which means the problem is over. All you have to do is add up these numbers. So this would be 181 minus 113, and literally the answer is as easy as, hey, make sure and write positive 68. So this net reaction is an endothermic reaction of positive 68. Hey, well, that one was easy. Let's try and do one a little bit harder. So first thing I'm going to do is this. Look at the answer. Remember, it's already given you the answer. Here's my answer down here. So here's how I'm going to do it. First thing I'm going to do I have a CS2 on the left side up here? Is there a CS2 on the left side of the reaction? Bam, right there. So I got a CS2 on the left. Now technically I need 2 H2Os, but I'm not worried about the 2. Right now it's as simple as I need an H2O on the left. And I'm looking up here and there is no H2O on the left. So this one actually has a little bit of work to it. So what I need to do is this. I need to make one of these equations. I need to flip it. All I'm going to do is flip an equation so that I get an H2O on the left. Which equation can I flip to get my H2O? The very first one, the one on top. You're right. So look at what I'm going to do. Oh my goodness. I'm going to rewrite this first equation. So watch this. And watch how I rewrite it though to keep it nice and neat. I'm going to write it completely backwards. Instead of this yields H2O and SO2, I'm just going to write it backwards. H2O plus SO2. And I've actually got people in front of me. I'm not talking to myself. What is the right side going to be? Dun, dun, dun. H2S plus 3 over 2, O2. This is the part that somebody will forget now. You still got to finish this thing. Delta H. So now think about it. If this reaction was exo 563, when you flip it, it's going to become what? Endo 563. And now I'll show you something else that's very important to do. Watch what I'm about to do. Watch this. And notice how I marked everything out. That first equation doesn't even exist. Sometimes I'll see a student do this problem. They'll mark out the equation but leave the negative 563. Well, then they end up adding that into it. The thing is, it's gone. Everything's gone. Matter of fact, what I like about what I'm doing is I can actually do this. I can completely be like, I don't see you. I can just get that thing gone because it doesn't exist anymore. So now let's go back to our thought process. I need a CS2 on the left. Bam, there's a CS2 on the left. I need an H2O on the left. There's an H2O on the left. Sweet. I need a CO2 on the right. There's a CO2 on the right. I need an H2S on the right. There's an H2S on the right. So all that's good. Now, I've got everything set up right. Now I need to look at two things. One, I need to make sure I got a CS2 on the left. Just as in one. Bam, there's one. So that's awesome. I need two H2Os on the right. Well, that's a bit of a buzzkill because when you look up here, I've only got what? One. I need one CO2. Got one. I need two H2S's. Y'all, this is just like an... What is wrong with you? This is just like anything else in the algebra. I need two H2Os. Can I get two H2Os? Yeah. All I have to do is this. Multiply this equation. What am I thinking? Yeah, multiply it by 2. So I'm going to multiply this equation by 2. But I can't just multiply the H2O by 2. I've got to multiply the SO2 by 2. I got to multiply the H2S by 2. And now what's going to happen to this? 3 over 2 times 2 means that's going to become what? That's going to become 3. So this big 3 there. Sorry, my eraser's too big to erase that effectively. So that becomes a 3. This is where somebody gets the problem wrong. Still like math. If you times that by 2, that's by 2, that's by 2, that's by 2, you still got to take the 563 times 2. And now you got to make sure and write this. Positive 1126. Get rid of the 563. Hey, we may be done with this one. I want you to look at something. I know I've got all my numbers right. Now let's see if things cancel. What do you mean things cancel? I mean, look at this SO2. Do you see an SO2 in my answer? Do you see an SO2 down here? Somebody said, uh-huh. Which means the SO2 should cancel. Look, there's 2 SO2s on the left. Look at what's on the right. Don't move it. They just cancel. They're gone. What else should cancel? I'm going to see if people in here know this at first. Yeah, there's 3 O2s and there's 3 O2s. So the 3 O2s are gone. And all I should be left with is my answer. CS2, 2H2O, CO2, 2H2O. I'm done. When you are done and everything cancels, all you got to do is grab your calculator, sum this up. So look at what I got. Negative 1075 plus 1126 equals, and hey, this is very important, positive 51 kilojoules. There's my answer to this problem. Hey, I'm going to do one more example in this incredibly long video and then give you a couple other tricks. The problems are really pretty easy. This one may be a little harder because if I got flip more than 2, I'm going to be pressed. Step number 1, do I have an S on the left in my equation list? Yes, right there. There is an S on the left. And I probably need to pause this video for a second because you need to copy it, don't you? And we're back. So hopefully you had time to jot this down. And so now what I'm going to do is I'm going to start my same thinking. I need an S on the left. Bam, got an S on the left. I need 2 OF2s on the left. Well, again, don't worry about the 2, but just look at the OF2. OF2, got one on the left. I need an SO2 on the right. Look at there. There's SO2s on the right. I got them. I need an SF4 on the right. Oh, no. I don't have an SF4 on the right. So find an equation with SF4, middle one, and flip that equation over. So I'm going to rewrite that middle equation. So that's going to be completely backwards. SO2 plus 4HF. And again, if you notice, I try and keep everything in a line like this. Makes SF4 plus 2 H2Os and delta H. If delta H originally was negative 828, now it's endo 828. And now I'm going to do something. I'm going to get rid of that equation since I flipped it. Be gone with thee. Oh, what? I didn't get the... Oh, somebody busted me. I didn't get the whole thing right. That 828 goes to... All that's gone. Now I want to start looking at some other stuff. I want to start looking at the numbers. I need 2 S's. So you should already be looking. I don't have 2 S's. So there's going to be a little bit of a problem there. Let's see. I need 2 OF2s. Dang it! I don't have 2 OF2s. I only have a OF2 up there. I need an SO2. Well, that's looking good. I've got an SO2. I need an SF4, and that looks good. Well, let's take care of this 2S. I need 2 S's up here. So go to the equation with the S. My color scheme still, ooh, I hate you now. So I'm going to multiply this equation by 2. But the thing is, I can't just multiply the S by 2. If I want 2 S's, I can multiply the S by 2, the O by 2, the SO2 by 2. And also, what somebody will forget, 297 times 2. I got to multiply the delta H. So that actually becomes negative 594. All right, cool. So I've got that done. Now I'm looking at this 2OF2. So I'm going to go multiply this equation by 2. So multiply the top one by 2. So 2LF2, 2 H2Os, 2 O2s. Now, this one's already got a 2 in front of it, so 4. Very good. So that becomes 4 HFs. And now I got to do the same thing. This negative 277. I got to times it by 2. 277 times 2 equals, and don't forget your negative sign. So that's negative 554. And y'all, in reality is this one's about as hard as it gets. So if you can follow this one, you should be good to go. Now I want you to look. I know I've got my numbers. Now everything else needs to cancel out of this problem. Huh? And this doesn't have one. Oh, wait and see what happens. Notice something. I just had somebody ask me in my real live class, if you notice, there's an SO2 here. There's 2 SO2s here, but there's only 1 SO2 in my answer. Oh, no. Look at something. 2 SO2s on the right. 1 SO2 on the left means what happens? That SO2 on the left cancels the 2 and leaves me with 1. So score. Look at something else. Look at the O2s. There are no O2s in my answer, which means the O2s need to do what? 2OF2, 2O2 on the, you got 2 O2s on the left, 2 O2s on the right, meaning they cancel. And the HF. What? Look. So there's 4 HFs here, 4 HFs there. They cancel. Is that good that they cancel? Yes. Why? They're not in the answer. Also, the waters. There's 2 H2Os on the left, 2 H2Os on the right. All you should be left with, this is how you know you're done. The only thing left should be this. 2 S's, 2 OF2s, a color change. And then SO2, Bill Gates, I'm coming for you. SO2, I got one. SF4, I'm done. All I have to do is combine these numbers. So this is negative 554 minus 594 plus 828. Negative 320 is my answer. I hope it's 320. If not, I messed something up. Okay. Hey, this will be my last hint. So listen to this. Sometimes you'll work a problem, and like the answer, I'm just making something up. The answer will look like this. This is the answer. And you get done. You do all this stuff right. You've canceled everything. Hey, listen. You've canceled everything. You've done everything right. But you look and you're left with this. This is what you're left with. The exact right answer, but it's doubled. So what do you do if you do everything right? You've canceled everything. You've flipped everything. But your answer's double. Yeah. You don't have to do anything crazy. Get your delta H. Then half your delta H and you got the answer. That is the only last trick. 18-minute long video of Hess's Law. Thank you for watching. I love you. Peace out. Hot wings. Donald Trump. And don't forget your color scheme. Love you, Donald. You're my man. Well, not really. But anyway, later, dude.